Hi ladies and gentlemen, this is Mr. Green. I am sending you this recording for Unit 4 review because you're going to be taking the Unit 4 test and I am not available to do a review with you right at the moment. So what I'm going to do is just go over a little review with you and make certain you've got it covered. Okay? Now, you should all be through Unit 4 and working through all that information. And you should be up to the point where you're taking the Unit 4 test. So I'm going to be doing the Unit 4. Don't forget, you can always make corrections. If you've got low grades out there, please read the corrections drop box and make corrections. It will help your grade. Due dates, things lock up 28 days after they're due, so you want to get them in. So let's get into this review and see if we can't get through it pretty easily. Okay? First of all, I want to identify all the congruent sides of a quadrilateral. Given two names, I am not even given a diagram here. I don't have to be given a diagram. All I have to do is look at the names. I see AB here and GH here. Those are going to be two sides of the quadrilateral that are going to be congruent to each other. How do I know they're congruent? Because they're in the same position as far as the name is concerned. If I look at the next two letters, BC, that's side BC, and it is congruent to HI. Let's write that correctly. HI, side there. Because those are the second two letters here in the second one. Okay? So the next two letters are CD, and that will be congruent to side IJ. So I now got the three easy ones done. That was IJ and CD there. What am I looking at for the fourth side? What's the first and the last one, or the last and the first? It doesn't matter how you want to look at that. They're the two that I haven't identified yet. So DA would be congruent to side JG. Okay? From the same perspective, even without saying this, I would know that angle A is congruent to angle G. I would know that angle B is congruent to angle H. I would know that angle C is congruent to angle I. And I would know that angle D is congruent to angle J. Why do I know these things? Because the naming convention of quadrilaterals and of other objects tells me that I put congruent things, corresponding items, together in the same order. So that's the way we would know which sides of the quadrilaterals were congruent. Okay? So if I'm looking at this, I've got two triangles sitting here. And the way I see these two triangles, I've got one triangle that goes from here. Okay, come on. Pins flying all over the place. Like that. There's one triangle. And then I've got another triangle that's a red triangle here that would be from here, like this. Hey, they had the same side there. I know that this side down here is going to be congruent to itself. That's the reflective property. Remember that one? We've got that. So we can always use that one. So they're saying if side AB is congruent to CD, they're saying this side is congruent to this side. See how I'm putting these tick marks on there? Those little tick marks are telling me that those two sides are congruent. I've got one here saying that one is congruent to itself. I've got two here that's saying that those two sides are congruent. And then they also tell me that BD, this side right here, is congruent to CA. That's this side right here. How can I prove these two triangles are congruent? Well, this is one of our three-letter acronym things. I've got a side, I've got a side, and a side on the yellow triangle. And I've got a side, and a side on the red triangle. That tells me that I would use side, side, side as my technique for proving these triangles congruent. Okay? Moving forward. Here I've got two triangles. And they're saying if BF and EC bisect each other. Well, if they bisect, that means that this will be equal to this, and this one will be equal to this one. Bisecting means dividing in half. So I just proved, well, I didn't have to prove it, it just told me that they were congruent to each other. I know that this angle, see how I make these little curve marks for angles? That's showing that those two angles are congruent to each other. Why? Because they're vertical angles. Well, now if I look at one of the triangles, I've got a side, an angle, and a side, or a side, an angle, and a side. So I think that the theorem that I would use to prove them congruent to each other would be side, angle, side. Two triangles again. Given that PR is congruent to RT, PR, RT. See how I marked them with that so that I would make certain I had that. And then angle QRP, well, that'd be this angle right here, is congruent to STR. That'd be this angle right here. What proves the two triangles congruent to each other? Well, the other thing I see is that they both have this right angle up here in them, okay? They didn't give me two sides, so I won't be able to use hypotenuse leg, even though that's one we normally think of when we think of with right angles. But I do know that right angles are always going to be congruent to each other, aren't they? They're always going to be 90 degrees, so they're going to be congruent to each other. So I now have an angle, and a side. And on this other one, I've got a side, an angle, and an angle. And I believe the theorem that we were given to do this was side, angle, angle. Might have been angle, angle, side. Write it correctly, Charles. Okay? Angle, angle, side. That's what I would choose as my correct answer. Moving forward. They're asking us to find the measure of angle A. Well, angle A is this one right down here. Okay? They've got 110. Oh, look at this. What does that tick mark mean? That means that this side is equal to this side. If those two sides are equal, that means that we've got an isosceles triangle. That means that this angle here is going to be equal to this angle down here. Well, that's A. That's what I'm looking for. If I just set a variable for that, they're going to be the same thing, aren't they? X and X. I can then use my triangle sum theorem. 2x plus 110 equals 180 degrees, because the sum of the angles is supplementary, right? I can subtract the 110 from both sides. I get 2x is equal to 70, x is equal to 35 degrees. Woohoo! I found the measure of angle A as 35 degrees. Wow. Okay. So looking at this one, it says, what's the measure of the vertex? Well, I know from remembering my definition of isosceles triangles, this angle down here is going to be equal to the 70 degrees over there. And this angle up here is the vertex angle. Okay? Now, how did I know it was an isosceles triangle? Well, they told me that. But they also showed me that these two sides were equal, so I know those two angles would be equal. I'm now going to use the triangle sum theorem, and I'm going to add them up. I'm going to use x for this variable up here. I'm going to say x plus 140. Where'd you get the 140? 70 plus 70 is 140 equals 180. I subtract the 140 from both sides, and I get that x is equal to 40 degrees. Okay? So having found that one, let's move on. This one, to prove that quadrilateral ABCD is a parallelogram, you must first prove that triangles ACD congruent to triangles CAB by using what theorem? Well, I don't know why they phrased the question that way, but they're wanting me to prove triangles ACD congruent to CAB. I need to make certain I know what triangles they're talking about there, because that's going to be confusing if I can't figure that out, okay? So ACD, A to C is right down this diagonal to B. I'm sorry, D. That'd be this way to D and up to there. There's my red triangle, okay? And then I've got my blue triangle, which was C to A to B, which is C to A to B. Okay, there are my two triangles. Now, what do they have marked on the triangles for me already? Well, I've got a side and a side, and I've got a side, and I've got a side. And you know what? I know that this one equals itself, doesn't it? It's in both triangles. That's a side as well. So I think that I would use the side, side, side theorem to prove the two triangles are congruent. If I can prove the two triangles are congruent, then they're saying we can prove the triangles as a parallelogram. Don't know how they did that, but we will go with that. Okay. Now, to prove diagonals of rectangles QRPN are congruent, you can use CPCTC after you prove triangles congruent. Oh, they're asking me what triangles are congruent. Okay? Well, we're wanting to prove that the diagonals are congruent. That means we need to make certain we're including the diagonals in our triangles that we're going to be proving congruent. And this is one of the hardest questions on this test, okay? Because you've got to be able to look at the diagram that they're giving you and realize that I've got to have both diagonals in the triangles, okay? And so what I'm doing is I'm highlighting a couple of triangles here, okay? I got to make certain one of them has one diagonal in it, the other one's got the other diagonal. And then it's a matter of making certain I write down the name of the triangles correctly so that I can find them in the answer choice, okay? So if I'm going from N to Q to P, and in the other one I'm doing from P to, let's see here, went up R to N. That's the way I've written those two triangles. I've drawn those two triangles. Now, the problem is what you're going to have in the problem that you have, they're going to have four choices for you to pick from. Make certain you know which are the triangles they're talking about. Make certain they've got both diagonals in them and that they're naming the triangles correctly. Then you would be able to determine which is the correct answer in this particular one. Like I said, hardest question on the test. Okay. This next one says, if the diagonals of a parallelogram are congruent, then the parallelogram must be a, okay, it must be a, well, let's see here. If we look at the theorems or the properties that we were given, quadrilaterals have bisected diagonals, but they're not necessarily congruent to each other. So we have to go deeper in from that, because one of the specifics of a rectangle was that the diagonals were congruent to each other. And one of the specifics of a, let's see here, the rhombus does not have equal diagonals. Now, I just want to make certain I draw that and make certain I'm looking at this. If you look at a rhombus, and I drew almost a square there, okay? In a rhombus, the diagonals, are they going to be the same? Not necessarily. They're going to be 90 degrees of each other, perpendicular to each other, but they're not necessarily going to be the same. Not a decent example of it. But if I drew a rhombus that is exaggerated, like this one, okay? In this rhombus, you can see these diagonals are definitely not the same length, right? So we know it's not true in a rhombus But we could see it as true in a rectangle because we know rectangles have congruent diagonals. Okay? So, what must it be if it has congruent diagonals? It must be a rectangle. Okay. If the diagonals of a parallelogram are perpendicular to each other but not congruent, what must it be? Well, based upon what I just showed you in this last one here, they're perpendicular but they're not equal. It must be a rhombus. These are all based upon the properties of quadrilaterals that we have been looking at. Okay? We're going back to an isosceles triangle here. It says find the base angle of this isosceles triangle. Well, we know these two angles are going to be equal to each other, right? And if we look at this, we can say that 40 plus 2x is equal to 180. And if I subtract the 40, I get 2x is equal to 140, and x is equal to 70. So we know that each of these angles down here are 70 degrees. You know what? I want to show you something. Tests are really good about getting context clues. This one, where we asked you the vertex angle was 40, and this one, we gave you the vertex angle was 40, we asked the base angle is the same. They're the same question, just a little bit differently phrased, aren't they? Check for things like that. They do that all the time in tests. Okay? Now this one, which of the following could be lengths of the sides of a triangle? Remember what I told you. Add the two smallest ones. If it's greater than the other one, then we're good. 7 plus 12 is 19. 19 greater than 18? No, not a triangle. 13 plus 7, 20. Is that greater than 22? Yes. No, I'm sorry, no. 20 is not greater than 22. No, not a triangle. Okay? 13 plus 10, 23. Is that greater than 22? Yes. That one is a triangle, or could be a triangle. Okay? 6 plus 13, 19. 19 greater than 18? Yes. That one could be a triangle. 15 plus 8, that's 23. 23 greater than 22? Yes. That one could be a triangle. 6 plus 12, 18. No. That one could not be a triangle. Going back to this first one, I realized 7 plus 12 is 19. Yes. Yes, that could be a triangle. Okay, check my answers there. Yes, they're correct. Didn't mean to confuse you there. You add the two smallest ones together. If they're greater than the third one, then yes, it could be a triangle. That's the technique. Okay? Now, for the part 2 of the test, you're going to be constructing a square. What I want you to do is I want you to go watch the recording from the Class Connect on 11/21. If you're in my regular honor or regular geometry class, 202a, in my 202a class, I recorded on 11/21. I went over the construction of a square in that class Connect. I also talked about determining the possible lengths of a triangle. Essentially, if I'm given two lengths, 7 and 15, and I'm trying to determine what the possible lengths of a triangle are, I'm going to subtract these two. 15 minus 7 is going to give me 8, and that means 8 is going to be my minimum value for the side length. Okay? I'm going to add the two together. 15 plus 7 gives me 22. 22 is going to be my maximum size of the other side of the triangle. That is the way you have to express the answer. It's really that simple. You add and you subtract. Okay? Okay. Well, this has been a review of the Chapter 4. If you have any questions for me, feel free to give me a call or send me an instant message or send me a K-mail. I appreciate when you're sending me things that you're telling me that you're in geometry in 202A and what section you're in, because then I can look your records up a little bit quicker and find answers and get them back to you quickly. Look forward to seeing you next time. Bye.